All right, looks like we're starting to get a fair few people join us now, so we might get underway. What's going to happen is this session's a little bit different to others that we have run, in that the first part with the general discussion is pre-recorded. That was so one of our academics, Joelle, could join us, but she is not able to today. So we'll play that video to start with to sort of get that discussion. Then afterwards, we'll hand over to Mel to take the live Q&A. So if you've got a question which you think of during this, just put it in the chat box and we'll be able to answer it after we've gone through the recording. So I'm just going to share my screen here and let's get started. All right.
So if you want to make a real impact in the world and you want to develop skills that make you very employable, then you might want to think about studying environment issues. Environment issues are core to a lot of the important challenges around the world. Challenges in how we feed people, how we have sustainable cities, how we manage bushfire, how we manage climate change, and so on. And it's a great opportunity to study environment issues at the ANU, because the ANU has the Fenner School of Environment and Society. And the Fenner School, we recognise that environment issues have got that dimension to do with the plants and the animals and the trees and the soil and so on, but they always also have a human dimension. That's the society part. And we bring both of those elements to anything we study. We have leading researchers in the school that are making a big difference in the world themselves, but also play a role in teaching the courses that we teach. So if you're really passionate about environment, we've got a degree just for you called the Bachelor's in Environment and Sustainability. And that's a course that focuses in the Fenner School but has opportunities in other schools. But actually, you might be more interested in doing a Bachelor of Science or Arts, or you might want to study law or politics and still bring some environmental perspectives into one of those degrees. And this approach is possible too. It's really easy if you're doing a Bachelor of Science to choose plenty of environment subjects and mix them up with a few others. But even those other degrees have generally got the flexibility to bring in courses from other schools. And we love having these students in our environment courses too. Either of these options are great, and the ANU is a great place to be doing them. I hope you think about studying environment at the
ANU. Great. Well, thanks everyone for joining today in this panel session. Just at the beginning, I want to mention that this webinar will be recorded and that the recording will be made available after the event. So you'll be able to ask questions or make comments via the Q&A tab, which is located at the bottom of your screen. And if you would like to send an email, alternatively, you can also do that. And we will leave those contact details in the chat window as well. Before we get started, I wanted to acknowledge any First Nations people who are joining us today, and that here in Canberra, we are meeting on Ngunnawal and Nam country. And I would like to pay my respects to elders past, present, and emerging. So this session will be conducted in two parts. The first discussion is pre-recorded. That's the one we're currently doing. And then we will broadcast this before the live Q&A during the ANU Open Week, where you will have the chance to ask questions to the panelists that will be available then. Okay, great. So let's go to the introductions. My name is Melanie, and I'm a PhD scholar here at the Fenner School of Environment and Society within the College of Science. And I'm doing research on losses and damages from climate change, with a particular focus on islands in the Caribbean and the Pacific. So if each of the panelists could just give a short introduction about themselves as well, that would be great. So maybe start with you, Joelle.
Sure. So I'm Joelle Gergis, and I'm a senior lecturer in climate science in the Fenner School. A lot of my work really revolves around understanding climate variability and change on a range of different timescales, from decadal timescales through to daily extremes. So using a range of different sources.
Mm-hmm. Great, thank you. Steve?
Sure. Thanks, Melanie. So my name is Steven Crimp. I'm a research fellow at the Climate Change Institute. And my research background really is similar to Joelle's in terms of trying to understand climate variability and climate change in the context of food production globally and potentially in Australia as well.
Oh, great. And last but not least, Mark.
Thanks, Melanie. My name is Mark Howden. I'm the Director of the Climate Change Institute at ANU. I'm also a Vice Chair of the Intergovernmental Panel on Climate Change.
Mm-hmm.
I've worked on sort of understanding the climate science, applying that climate science to solve problems of climate variability, climate change, working out how to adapt to those changes. I've also looked at greenhouse gas emissions, both how to count them and also how to reduce them. And I've dealt a lot with science policy, so how science interacts with policy, and also with many different community groups across Australia and the world. And so I've sort of covered quite a few different dimensions of climate change.
Wow, great. Thank you so much for giving an introduction. So now the first question, and probably the biggest of them all, what is climate change? If each of the panelists would put their thoughts together and looking at the definition of climate change, what it encompasses, or how we can measure this, or what the impacts are as you see them. Who would like to go first for this one?
I'll start then.
Yeah.
So one of the things we know from the long history of the Earth, so this goes back billions of years, is that our climate has changed many, many different times. And in our more recent history, so for example, we had a very much warmer and wetter climate when the dinosaurs were around, so they were in very different environments from the ones we have today. In our more recent history, we've had a series of ice ages and then periods between ice ages where the world has gone cold and then warmed up somewhat and then gone cold again. And in our last 10,000 or so years, we've been in one of those warmer periods between the ice ages. And so there's change happening at that sort of 100,000 year scale between ice ages. But what's happening now is very different from that because it's actually human driven rather than natural in its cause. So humans are producing lots of greenhouse gases. These are like blankets in the atmosphere. So when we drive our cars, turn on our electricity, we generate things like carbon dioxide and methane. And so what they do is they hold some of the heat in against the Earth that otherwise would escape out to space. And so this means the world warms up as we increase the concentrations of those greenhouse gases in the atmosphere. And when we're talking about climate change, it's not about what happens today versus tomorrow or next week. It's actually about the longer term. So it's the longer term trend, like, there's like a 30-year trend in what's happening. And what we can say very clearly is that the world is warming, Australia is warming, and a lot of other things are changing, such as ocean currents and ocean temperatures, changes in rainfall in some places, which are also due to climate change. And they mean that some of the things we've done in the past are no longer the best things to do now, and that may change again in the future.
Great, thanks for that. Very good start into a definition of climate change. Steve, I was wondering, because you said you work on agriculture, how is climate change impacting the area in agriculture and food production in Australia or maybe also overseas?
Sure, thanks for that question. So as Mark was saying, we're starting to get unprecedented rates of change in climate. So the greenhouse gases that are accumulating in the atmosphere are basically resulting in changes in rainfall patterns and warming in the atmosphere. And this is happening at different rates around the world. And they're having impacts on areas in which crops are being grown. So in some areas where crops are being grown in the drier margins or drier regions, because of that warming and drier conditions that are actually starting to eventuate, we're starting to see impacts on productivity and actual production of crops. And so particularly in the Australian context, where crops are grown in reasonably dry conditions, where the average rainfall is actually quite low, because of that warming and because of the changes in reduction in rainfall that we're seeing in Australia, starting to see that the production is becoming more variable, and we're starting to see that the actual quality and the nutrients that are associated with those crops are also changing. So as Mark said, the greenhouse gases that drive the greenhouse effect, one of those, and one of the most important ones, is oxide. And we know that carbon dioxide actually has a positive impact on crop production. It makes crops actually more water use efficient. So it makes
Steve, I think you just broke up there a little bit. Would you mind just repeating that last bit again, where you said that carbon dioxide can make food production more efficient?
Sure. So what happens with carbon dioxide as the emissions are growing in the atmosphere? The carbon dioxide allows the sort of crops to grow under more water limited conditions, so they become more water use efficient.
Okay.
But what we're seeing is that in some regions where there's been significant change in rainfall, we're seeing declines in production of crops. And in other areas where we're not seeing as significant change in rainfall, we're actually seeing improvements in production. And so geographically, the regions of global food production are actually starting to shift. So where traditionally there would have been fairly significant production of crops, we're starting to see those regions shift to other traditionally colder areas. And so we're also seeing that some crops are becoming more difficult to grow, particularly those that require a lot of water. Starting to see more challenging conditions for particular types of crop production.
Okay, and what impact does that have on people, farmers, for example?
So if you think about the impacts on crop production, if we're starting to see changes in productivity, that leads to changes in the availability of staples and other foods. And so if they're becoming harder to produce, the cost of those crops actually increases, and so the sort of cost of food staples actually goes up as well. So we're starting to see that the supply of staple foods is becoming more variable. The cost of those particular foods is becoming becoming more volatile, and we're also seeing that the quality of the foods that are being produced as a function of climate change are becoming more variable. So more nutrient poor, and in some instances you're having to apply a greater amount of fertilizer in order to get the same sort of response to that crop growth.
Great, thank you so much, Steve. And Joelle, what does climate change mean for you when you think of a definition of climate change, or how we can measure it in the work that you're doing?
Sure. So when we talk about climate change, I think it's helpful to try and distinguish the causes of natural climate variability, so things like changes in the ocean or the atmospheric circulation of the Earth, and things like volcanoes and solar variability. These are all natural fluctuations in the Earth's climate. But when we start to think about climate change, it's this introduction of human activity into the system. So that is changing the land surface in terms of the availability of vegetation to soak up that excess carbon in the atmosphere, and also the burning of fossil fuels to really fuel human society and activity. And so it's this balance between human activity and the Earth's capacity to balance out these greenhouse gases in the atmosphere that really start to be altered by human activity. So to be able to understand climate change, we have to understand what are the natural background rates of change and the sorts of climate variability and extremes that we experience, particularly in a country like Australia. So we're often referred to as the land of drought and flooding rain. So we have really high year-to-year climate variability. And we have a range of different climate factors that influence the sorts of conditions we experience in things like droughts or heavy rainfall events and cyclones and so forth. And so a country like Australia has very diverse climate drivers. So we have the Indian Ocean, the Pacific Ocean, the Southern Ocean. And so getting a good handle on what is the natural background variability like in a country like Australia is really important for starting to tease out the human fingerprint, if you like, on the climate system. And so to be able to look at these long-term natural climate cycles, we have to start to, well, firstly, we use a range of different records. We use meteorological observations where they're available. But in Australia, they begin around 1900. So to go back further, we have to use other types of records. And this often involves using things like tree rings and corals and ice cores, so these natural archives, so records from the natural world. And they go centuries back into the past. And by looking at these fluctuations in pre-industrial climate, we start to get a sense of what is background variability and what is starting to become enhanced by human activity. And you can tease this out using climate models. So you can actually start to look at the different variations that you see in these different data sources and start to compare them to climate model simulations that are run with and without human influences on the climate system. And so that type of research is very active at the ANU. So that, there are researchers that are working on coral records, tree ring records, ice core records, and also I work on trying to recover early instrumental records, so records that were kept by early colonial settlers and the first observatories we have in Australia. And we pieced together these day-by-day records of climate variability and extremes. And why that's important is we can start to look at the past and think, well, okay, if we had a really severe heat wave or an event that was had a big impact on society, what would happen if we start to see these events playing out on a warmer world that is warmer by, say, 2 degrees, 3 degrees, or even 4 degrees into the future? And then that starts to have really big impacts on the things that, say, Steve was talking about in terms of agriculture and the bounds of, a safe operational environment for human societies to operate in. And so we need to understand the sorts of climate risks that we have in a country like Australia and also around the world. And so understanding the fundamentals of how the climate system works, how it's changing and how it impacts human societies becomes really important. And to do this, we have to understand the fundamental science. And that's what we are trying to do at the ANU, I think, in many ways. And I can talk more about what we're teaching when we get to that question.
Yeah, great. Well, that was a fantastic transition into the next question. Actually, you've already answered it, talking about what research is the ANU doing into climate change. So I might just give that question to Steve. What is the research that ANU is doing into climate change, looking at climate science, policy, measuring data, or research into mitigation and adaptation methods? So if you wanted to give us a little bit of an overview of that, that would be great.
Sure. Thanks, Melanie. So in terms of some of the different types of research that are done, if we think about, first of all, looking at, as Joelle indicated, trying to understand what the actual future climate will be like under different emission scenarios, and getting a clearer picture on what those climate futures or future conditions might be like is something that ANU is contributing to, and in partnership with the Bureau of Meteorology and CSIRO. What is important, though, is if we move from that point in terms of understanding the potential changes that are likely in the future, we need to also then understand what the impacts are on infrastructure, on agricultural food production, on a whole range of different sort of human and sort of non-human systems. And so we have to integrate that climate information into that systems knowledge.
Mm-hmm.
From my perspective, in terms of what we're looking at in terms of agriculture, we're looking at the sort of risk that climate change poses to the sort of value chains or the supply chains that make up our food systems. We're looking at the implications of climate change in the Pacific and to those particularly vulnerable groups in terms of their food security and food stability and food sovereignty. We're looking at how we can actually use our knowledge of the climate systems in terms of the variability and our understanding of those different drivers, and understanding how we can actually improve our prediction of those systems and produce early warning systems that allow us to respond to unfolding climate events. And so that's sort of looking at climate variability and seasonal climate forecasting, and looking at novel ways of combining our mathematical understandings and statistical understandings in ways that allow us to aggregate different parts of that climate science understanding together to produce these sort of forecasting systems. The other things that we're also trying to understand is, because you imagine that these systems, there's a strong human element to these systems, and so we need to understand human responses. We need to understand how we actually tackle climate change and need to think about how we reduce our emissions. And so thinking about ways of engaging with communities, policymakers and governments to think about addressing and reducing emissions is something that we're also looking at here at ANU in terms of that policy response. And we're also looking at sort of novel ways of trying to innovate so that we have some sort of innovative response to climate change and those particular elements that I talked about before in terms of dry conditions. So how do we improve our capturing of water or water use? How do we improve the efficiency of our transport systems so we reduce emissions from them? So in terms of dealing with climate change, we're not just focusing on the science of climate change, but we're looking at how that science is integrated across policy, across agricultural systems, across other biophysical systems, and trying to get a clear understanding of what the future holds so that we can adapt to that more effectively.
Great, thank you. And Mark, you as the director of the ANU Climate Change Institute, maybe you want to give us a little bit of an overview what you are doing, maybe in regards to the international report or climate change policy or international negotiations.
Yeah, thanks, Melanie. So just to, before I do that, just to add a little bit to Steve's
sort
of list and what Joelle talked about as well, is that as well as that sort of climate science and how climate impacts on systems, as well as the sort of agriculture and urban systems Steve's talked about, there's water, health, psychology and mental health, legal systems, forestry, building standards, et cetera, et cetera. So there's many, many different systems in Australia that get affected by climate, and so we need to understand something about what those impacts are and how to deal with them. And as well as that side of things, there's also lots of work going on in terms of policy work, and particularly in terms of energy and energy policy, and also work on energy and electrical systems and how to redesign them, so go to a transition towards renewables, and which is increasingly important. And it's not just the technical aspects, but also the social aspects of those transitions. And then we've got work which is going on in terms of removing greenhouse gas emissions from the atmosphere, both through natural processes and through technical and industrial processes. There's a whole spectrum of different activities that happen at ANU, and many more than I've just outlined there. And the job of the Climate Change Institute is to try to coordinate and facilitate some of that work within ANU and between ANU and partners in government and in business and in community. So we actually have a better interface between the people with the problems and some of the people with the solutions, which includes the academics, and also to essentially have an education element with the public. And so we run events of different types to raise the level of awareness of climate change. And then we respond to things like parliamentary inquiries and the Bushfire Royal Commission, things like that as well. So we coordinate responses across ANU for that. Amongst many other roles, I also work on the Intergovernmental Panel on Climate Change, but I've got about a dozen different advisory and roles across Australia and the world. And so some of these are at community level, some at state level, some at national level, and then a few at global level. And the IPCC is a particularly important one because that brings together the best understanding of science and communicates that to policymakers in a way that hopefully they can use and understand and use. And both Joelle and Steve are also involved in the IPCC. So Joelle's a lead author, and Steve is on the task group for data. And so across ANU, I think we've got now 7 different IPCC participants in different areas of work. So the IPCC has been going for over 30 years now, and it is the single most, I think, adventurous science experiment that humanity's ever tried. And so it's actually involved huge numbers of people, huge numbers of stakeholders, huge amount of output, and the processes to develop that are incredibly rigorous and robust. And so IPCC is a great source of information if you're wanting to put a project together on any aspect of climate change.
Great, thank you so much, Mark. So now here at Fenner School in particular, we're really interdisciplinary, and we work across a wide range of disciplines within the academic community. So how and why is climate change also so relevant to other areas of science, or also other degrees here at ANU that have to do with the environment or international relations? Joelle, maybe you want to comment on that a little bit.
I can't think of anything obvious to say here aside from I think that, climate change influences all aspects of life in many ways. And I think that while we do want to do our best to understand the fundamental science, obviously humans need to be able to adapt and societies need to be able to function. So it isn't just purely a scientific problem that we're dealing with. We're also dealing with societal issues and political complications, and basically it's a really complex problem. But maybe the others are able to speak to this. It's not really my area. So
I can give it a very quick shot, but Joelle's said the critical thing, which is climate affects almost everything we do, and almost everything we do affects climate. And so the university as a result has many different courses right across all of the different schools and all of the colleges which deal with climate change. So for example, in the Climate Change Institute, every college, the 7 colleges at ANU are engaged with the Climate Change Institute, and 25 of the 27 schools across ANU have engagement with the Climate Change Institute. So there's a huge number of courses which have climate change or as a large part of the course, or sometimes as a small part of the course, but it's right across ANU.
Oh, great. So that actually leads very well into the last question that I have to all of you. If we now have a student that would love to learn about climate change, where would they start, and what would they learn at some of the courses here at the Fenner School?
Maybe that's something I can start with, given that I recently joined the Fenner School about 18 months ago, and I've restructured some of the climate science that gets taught in the school. And so we're trying to make it really a multidisciplinary approach to climate science. So you don't necessarily have to come out of out of these courses being a climatologist, if you like, but understanding the fundamentals of what it is that drives the climate system and the main fundamental ideas are there. So we have a second year subject called Fire, Flood and Drought, and that is a subject that I co-teach with Jeff Carey. And that subject really looks at the fundamentals of Australian climate, climate variability and extremes, and we look at really trying to understand what drives Australian climate and those types of impacts. And obviously things like extreme bushfires or droughts or flood events and other heavy rainfall events, and just understanding the fundamentals. And then in third year, we have a new subject called Climate Change, Past, Present and Future. And that very much looks at taking students on a journey from deep time, from these ice ages, through to future climate. So we have a bit of an overview of some of the main aspects of these long-term variations in the climate and what drives it. And then we move on to thinking about how we monitor the contemporary climate, and then into the future climate. How do we actually distinguish natural variability from human-caused climate change, and also these different climate change scenarios? So what will the world look like with an extra, like 2 degrees, 3 degrees or 4 degrees of warming, global warming? So, but I think the main thing I want to say is that it really does try and provide a multidisciplinary approach. And there's a lot more collaboration between the Research School of Earth Sciences and the Fenner School at the moment. We're trying to bridge those gaps and provide opportunities for students with a range of different skills and interests. So in terms of, on the spectrum, you might be somebody that is more from the arts, but you can still take some of these subjects to get a better handle on the fundamentals of climate science, but then you might be someone that might be interested in more of the mathematical or statistical aspects, and you can take courses in the Research School of Earth Sciences to complement what you're learning from the foundational basis we're providing in the Fenner School. So there are a range of different climate science options, but that's what I teach. So I'll probably stop there so others can comment.
Yeah, great. Thanks so much for this overview of the courses that we have here at Fenner School. Is there anything, Steve, you lectured in some of the Fenner classes as well? Is there anything you wanted to add maybe from the policy side of things?
Well, just to let people know that we are actually offering a new master's level course next year, which is around agricultural systems, and we'll cover a range of these issues around risk to value chains and supply chains, looking at agricultural production and innovation and adoption. So, I think that there are a number of different master's courses that actually do have a fairly sizable climate change component as well that are offered by the Fenner School. But I just reiterate what Joelle said and what Marcus indicated earlier, that climate change is a multifaceted problem, which will require sort of multidisciplinary skills to actually solve. So within ANU, we have broader offerings from mathematics, from engineering, to law, to policy at Crawford School. All of these offerings do have some elements of climate change and do deal with climate change to a greater or lesser degree. We do teach into those and provide some context relevant information around the implications for climate change in those specific contexts. And I just encourage people, if they have questions about how they can actually pull together a degree that includes sort of exposure to climate change and the relevance to other areas, that they contact their sort of coordinators or other people like myself, that we can actually provide them with some indications of the things that they can bring together to sort of best service their interests.
Great, thank you. Mark, is there anything you'd like to add in terms of what is on offer here at ANU or at Fenner School in particular?
Look, I think the others have covered that quite well. And if you want to look for courses with climate change, you can just start by searching for climate in the course selectors. and you'll pop up with many different courses which have climate in them across the different schools and colleges. I think it's important to think about this not just as an undergraduate sort of elements, just so, you know, doing your degree after school, but ANU and other universities also have master's programs. We also have PhD programs, like you, Melanie, doing your PhD on climate change. And of course, there's careers in terms of climate change as well in all of those different things that we've talked about so far. And as well as that, we also provide professional short courses for people who are working, say, in the public service or in industry to bring them up to speed with the latest climate science and the application of that. So I think it's really important not to think of this just from the lens of doing your degree, your bachelor's degree, but actually thinking about it as a whole of career choice.
Great, thank you so much. And even though I'm the moderator, I'm also doing a little bit of tutoring and lecturing here at ANU, and just letting you know, in the undergraduate classes, there are also things like sustainable development. We're talking about environmental policy making here in Australia, also international policy making all over the world, within the United Nations. So there are a range of courses that you can study in a variety of disciplines. So yeah, and like Mark and Steve and Joelle said, if you have any questions, you can get in touch with someone from Fenner School, or just post something in the chat box now. So I am now finished with my questions, unless some of the panelists want to add something else. I want to thank you for this pre-recording, and we would now move to our live Q&A.
All right, so I'm going to pass over to you now, Mel, to go through the questions, and we will pitch these to Stephen and Mike. So if anyone's got any questions, please put them in the chat box, and thanks, sorry, the Q&A box, either works. So thanks to those who've already asked so far.
Thank you, Pete, and thanks for everyone who's listening here at the moment. We have a few questions coming in, so I'll try and go through them one by one, and if I miss one, please just say again that I haven't asked that question yet. So the first one is, and I think I'm gonna direct that one to you, Steve. What is the biggest challenge for urban areas in Australia and around the world in terms of climate change?
Well, thanks, Melanie. Thanks for the question, Elise. So I think from an Australian perspective, if we think about the background total rainfall that we have, we're in a fairly dry environment. And so as our urban areas grow, they put greater and greater demands on our water resources. And that increases the tension between the water that's used for urban purposes, for agriculture, or even for the environment. And so what we're starting to see in the Australian context in terms of some adaptation is that there is an increase in the desalination and in some cases some limited recycling of water. And so I think in the Australian context, you know, the big challenge that we have will be around how we manage our very scarce water resource in the future. And as our urban areas grow, how we accommodate those areas and actually make those areas resilient to climate extremes. So a lot of the urban areas that we have around Australia are at sort of, they're at sea level, and so are predisposed to sea level rise and predisposed to a whole range of other extremes. And I think from the perspective of the globe, I think what we are starting to see is a change in the frequency of climate extremes, and we're starting to see the significant impact that those changes in the frequency and the intensity of those extremes are actually having on urban environments. So I think those are probably the sort of big challenges in terms of Australia's water and extremes, and other urban areas would be how they manage and cope with climate extremes.
Thank you so much, Steve. Mark, would you like to add something to that?
Thanks, Melanie. I mean, it's a good question. I mean, there is the water issue, there's greenhouse gas emissions. So as more people pile into cities across the world, that means that there's more people producing greenhouse gas emissions and in the cities. So keeping a sharp eye on options to reduce those greenhouse gas emissions are really important. With increasing temperature extremes, we're seeing really important to manage heat stress within cities, because often we get that sort of urban heat island effect, and so we get hotter temperatures in cities than the surrounding countryside. So that's a big challenge as well. And I think another big challenge is just how do we include climate change considerations in with all of the other issues that urban planning has to deal with.
Great, thank you so much. And then I have actually, it's two questions from someone. One's directed at me, but there is another one also for you, Mark, and I might do that one first. So regarding the IPCC, how do you respond to David Spratt's critique that IPCC underestimates the seriousness of the problem, either to mollify governments or as a result of methodology, averaging all members' inputs?
Yeah. I guess firstly, the IPCC does not average all members' inputs. So it's a significant misunderstanding of the process. So what IPCC does is pull together the best understanding of the science across the world, and we put that we synthesize that. In that synthesis, we try to say what we know and also what we don't know, because there's many things we don't know in terms of climate change. And coming out of that is a series of messages from the science community. Now, those actually do get processed in a sense by the governments in what's called the plenary sessions. And those sometimes do change a few words in terms of the conclusions that the science community has drawn. But the messages within that remain very robust. And in fact, the science community pushes back very strongly if particular governments try to force particular messages into the IPCC. And to their credit, many other governments do push back as well. And so I actually think that the IPCC remains a very robust assessment of what we know in terms of the science. Now, having said that, yes, there are risks that we do underestimate both the rates of climate change and the significance of those impacts of climate change. And I think that's coming through in the science. So the science is progressing as science does, and our understanding is growing. And what that shows is progressively over time, we are getting more and more concerned as a science community about the implications of climate change, because both the rates of change are at the top end of our scenarios for greenhouse gas emissions and greenhouse concentrations in the atmosphere, rates of change in terms of climate. And so they're right at the top end of those things, but they're actually impacting on systems in ways that we did not anticipate. So with combined impacts of climates rather than single changes. So it's not just about temperature change, it's about temperature change and rainfall change, and change in extreme events, etc. And so I think the science is faithfully represented in IPCC processes, but those processes, of course, are fundamentally dependent on the science, and that's improving all the time.
Thank you so much, Mark. And then I hope that answered the question comprehensively. The second part of the question was why sea levels are rising in small island states, causing a lot of damage, but apparently not in Hawaii, where hotels are built right down to the beach. So the question was directed at me. So maybe someone, Mark or Steve with a more scientific background. So you raise your hand. Okay, I'll just pass it on to you then straight away.
So the response to that question is the reason sea level is rising. Obviously, there's a there's two main drivers, and one is that as some of the polar regions are melting, we're getting this increase in fresh water into the salty water of the oceans, and that's causing expansions. But overwhelmingly, the largest expansion is through heat, so we're getting thermal expansion. The reason they're different rates around the world is because the bottom topography or bathymetry of the oceans is uneven. So some areas it's quite high and others it's quite low. And so that's why we have variable rates of sea level rise across the Pacific. So Hawaii in particular is a volcanic island. It has a reasonably deep bathymetry, whereas other Pacific islands, which are atolls, which are very, very sort of limited in terms of their elevation, those are the islands that are currently being impacted most significantly now by the historical sea level rise that has been experienced. And so those islands in particular are having problems with inundation, with erosion, with saltwater intrusion into their freshwater sources. But the volcanic islands, because they have more altitude or they have more elevation and their coastlines and bathymetry tend to be deeper, we see that the impacts of sea level rise are not as pronounced. Although even in the Hawaii example there are well documented impacts on some of the in terms of erosion around the coastal zones, loss of mangroves and loss of other sort of coastal regions, productive regions. And also there has been problems with inundation in some of those more populous areas in Hawaii.
Great, thank you so much, Steve. I think, Mark, you raised your hand. Did you want to add something to that?
Sure, just a little bit. And that is that, so even if we didn't have climate change and sea level changes as a result of that, is that some parts of the world would be going up in relation to sea level and some would be going down. And that's because the Earth is not static, it moves. So for example, if you go into parts of Northern Europe, they are still rebounding after the last ice age. So where they used to have kilometers of ice on top of them, which pushed the land surface down, is that because that ice has melted, that land surface is still coming up. And so you actually see sea level fall locally in some of those areas. So as an example of what's called isostatic movement. And so the net change can be quite dependent on whether that isostatic movement is going up or down, combined with that sea level rise. And also part of that variation across the globe is associated with changes in ocean currents. So for example, in Southeast Australia, the East Australian current is coming further down the coast, which not only warms the water, but it also essentially piles water up more than it used to do. And so you see a relative sea level rise higher in that circumstance than you would otherwise do. So there's many different elements that come in, and you do get local variation in sea level rise because of those reasons.
Great, thanks so much for those two very comprehensive responses. There's someone thanking Joelle for her wonderful book that she published last year, and we will pass that on. So also always good to get some praise. Okay, so and then we have someone who's interested to know how or whether we cover the destruction of animal food production and climate. Apparently, or it seems you're focusing on working with what we currently have rather than changing to plant-based. I might pass that to Steve because you're working on agriculture.
Thanks, Melanie. Look, I would just say that when we think about adaptation to climate change, we think about adaptation at different scales. So you can look at sort of changing or small changes to what's currently there, and we call that sort of incremental change. And so that is really, trying to understand how we keep the same systems going. But we're not exclusively looking at just incremental change. We look at other tiers of adaptation as well. So we look at systemic adaptation, which is more progressive and more expansive and more risky types of adaptation. And then we also look at transformation. So that's transformational change, which is, I think, what Lisa's talking about there, is where we're looking at sort of changing from animal-based to plant-based proteins. And so we look at all of those scales of adaptation, but you need to understand that in terms of adaptation, it is a journey. And so people tend to start at the incremental scale because there's less risk involved and it requires modification of existing systems. But if we are going to experience the range of climate change on the more extreme side, then we will need to think about systemic and transformational change or adaptation that will involve looking at a range of different innovative ways of creating or producing protein, making sure that we're not impacting on those threatened environments in ways that are already sensitive to human impacts or climate change impacts.
Great, thanks, Steve. And I guess it sounds like as if there's still a lot of research needed, how we as a society can transition to a more plant-based diet. And of course, that's something that Fenner does. We go into research in those sort of areas, and also for the undergrads. Mark, anything you'd like to add to that as well?
Look, I think the sort of focus that Steve had was in focusing on the adaptation side.
Yeah.
But there's also the greenhouse gas emissions side that I think this particular question was trying to address. And certainly in some courses, we do look at greenhouse gas emissions, including from agriculture. And that includes discussions about the pros and cons of different mixes of greenhouse gas emissions, and in the case of emissions associated with food, which are very significant, the food system generates around about 29% of greenhouse gas emissions across the globe, so it's a very, very substantial contributor. Clearly, there needs to be reduction in those greenhouse gas emissions, just like in every other sector, and what we find very clearly is that we can reduce those greenhouse gas emissions through things like food choices, which not only reduce those emissions, they alleviate pressure on water systems because plant-based foods are often lower water demanding. They also have significant health benefits. So we can demonstrate the health consequences of different dietary choices, going very high meat versus flexitarian or vegetarian sort of meals choices, but also it's oftentimes lower meat diets are cheaper for people, not always, but sometimes, and so really when we need to talk about these things, we need to talk about the multiple dimensions of dietary choice, and how that then propagates through to industry behaviours.
Thank you, Mark. And I have another question here from Alessandra. It's very topical about COVID. Do you think that COVID has either increased or decreased the urgency surrounding climate change action? And if it has decreased, how do you think we can reinvigorate the sense of urgency? Maybe I'll pass this to you, Mark. Yeah.
Sure. What COVID showed was that, at both individual level, at governmental levels, state and federal, and also to some extent at international levels, we can respond to these sorts of threats very quickly and very substantively. And we also see different success in responding to COVID. So from largely uninformed responses to evidence-based responses by governments. And we can see the consequences of those choices in how to respond coming through. So for example, Australia or New Zealand versus the US is one example, very similar sort of societies in many ways, but very, very different consequences in terms of COVID response. So the good news is that this has demonstrated that we can make very quick, quite costly decisions in the face of significant uncertainty. And the challenge for us then is to move that preparedness for substantial and rapid responses from the coronavirus domain into the climate change domain, where in fact I would argue we know a lot more about climate change than we did and still do about coronavirus and how to deal with it. So a lot of this has to do with political will and the preparedness of our politicians to take on board the evidence based on climate change. And so I think really importantly, we need to keep some pressure up for good evidence-based decision-making in relation to climate policy.
Great, thanks so much, Mark. Very interesting insight there. And I think the Climate Change Institute has also running some seminars and courses on the impacts of COVID on climate change and vice versa. Steve, yes, you're raising your hand there as well. Do you want to add something to Mark's response?
Just to add to that, I mean, we've just finished a major study on the impact of COVID, the COVID pandemic on Indo-Pacific food security. And one of the things that is very clear from that assessment is that climate change is a threat multiplier, and it's actually exacerbating the impacts that the current COVID-19 pandemic is having on food security. And we know that we're going to have more of these situations where we have shocks to our system, and because of the underlying impacts of climate change and climate variability, the ability of those systems to actually accommodate those shocks is actually being undermined. And we certainly see that in countries that are being impacted heavily by the extent of climate change that they've currently experienced.
Thank you. So we have a few more questions in the Q&A box at the moment, and there's one about how ANU can help to tackle issues of the environment in their home country, in Nigeria in particular, or the world at large. Would you like to give a response to that, Steve?
Sure. So just to, one of the things that we actually ran successfully last year was a short course where we had representatives from across Africa come and actually study at ANU. And we actually have quite a well-established network of people around the sort of across the African continent. The idea was that we would be able to present information about climate change, and that information then would be taken back to those countries. And we worked with the individual participants to establish a plan of action for how they might actually change, or how they might take the knowledge that they've gained through the course and apply that in their work environment, or in their studies, or in their day-to-day life. And so the idea is that we do run these courses from time to time, and so I think that, you know, the response to that particular question is that we do cater for that on a sort of not quite an annual basis, but potentially a biannual basis. And I would encourage people to apply for the next round of that particular course when it does come up in the near future.
Great, thanks so much, Steve. Just wondering where, if students are interested in that, or especially coming from with an international background, where would they be able to go to find that information? Is there a website? Could you maybe post something on the chat, or is that something you could do, Pete?
Look, I can provide some. So our short courses, our Africa Awards short courses, are actually funded through Palladium, with funds made available from the Department of Foreign Affairs and Trade.
Right.
We have an existing contract with Palladium to deliver short courses over the next 3 years. And Palladium actually send out sort of reminders or expressions of interest around their networks. So I would encourage people to look at the Palladium website, because those award courses will be actually advertised through that institution.
Okay, great. Thanks so much, Steve. Mark, is there anything you want to add maybe to that question as well?
In relation to Nigeria? And
how ANU could help students tackle issues or find solutions for their home countries or for the world as a whole, I think was the question.
I think in a sense that is one of the strengths of courses at Fenner and ANU generally, is that it's that ability to, or that focus on treating solutions to environmental issues, not just on a technical basis, but also understanding the societal elements and the policy elements. So ANU has one of its, in a sense, three pillars as policy. So we see the pillars as research, teaching, and policy engagement with particularly the Commonwealth Government in Canberra. And so for me, a lot of the time in the past, just a too strong focus on the technical aspects has actually mentioned that the ability to change the systems, which is the question about this, how to actually improve environmental outcomes in different countries. It's really important not just to know about how to change the system, but to know about how to go about changing the system. And that's one of the things that ANU helps students understand.
Yeah, great. Thanks so much. I like, really that link and also between the university and the government. So I think that's really helpful for some of our listeners. So I have another question here from Elise. How do public health services have to change in order to respond to climate change impacts? And what kind of abilities are necessary in order to undertake a PhD related to climate change at ANU? That's two big questions. I'm just going to maybe pose it to either of you who wants to have a go at that.
Sure. Look, I can have a start to there.
Yeah.
So the focus here is on public health services in response to climate change. So what we see within public health services, they vary tremendously from country to country. So even within developed country environments, you'll see very different sort of ways of dealing with public health and different emphases in terms of policy. And so there is no single answer here. But clearly what we're seeing increasingly is major public health issues associated with climate or climate-related events. Whether it's heat stress, which can kill many thousands of people, as we've seen in places like Europe, or smoke from bushfires, which has significantly affected many Australians due to the smoke events from last year, but similarly people on the west coast of the US or other places which are affected by smoke. And so firstly, there's this need to understand the changing boundaries of what the public health services have to deal with that are associated with climate change. Then it's about both building capacity within those services, both it's the personnel, it's the understanding and training, capacity building in terms of staff. But then there's a public health communication role, which needs to happen. So it's about how to engage with the public so that they understand the changing nature of risks and what to do about it from a personal point of view, and how to seek help if they need to, if things get too bad beyond the self-management aspects of that. Yeah. And so public health is a very many dimensioned thing. And so you need to address each of those dimensions to have a good climate change response. Yeah. And in terms of abilities to undertake a PhD, so pretty much like any PhD, you in a sense have to convince your potential supervisors and the university that you have the capacity to undertake independent research, that you have an idea about what you want to do, and you have the commitment to drive it through, because PhDs can be quite difficult things to finish.
Yes, thank you so much, Mark. And definitely you need to have a passion for the topic. I find that is really, really important. So be passionate about what you do and be convinced about about your PhD. So speaking from personal experience. Steve, is there anything you'd like to add? We're almost running out of time. So yeah, so about the first question about the health, and then maybe what you think you need in order to do and finish your PhD at ANU.
Okay, just very quickly on that first question, I think one of the situations that we face at the moment is most of our public health services are quite reactionary, and there's less emphasis on actually strategic planning. And I think if these public health services are going to be able to respond effectively to climate change, there needs to be more strategic planning in place in terms of identifying how their services need to accommodate the actual climatic changes that we're seeing. The other thing I think from a sort of international perspective is that one of the things that we probably need to gear up is our rapid response to these events, so that we actually have in place the ability to respond rapidly and to deploy resources to respond to these events. That still is quite an issue in terms of how we respond to climatic events at the moment. And I think that could be improved, particularly if we're going to see more intense and more frequent climatic extremes. So just in terms of the last point, in terms of what it requires to do a PhD, I would just encourage people who are interested in doing PhDs to get in contact, look on the website, look at people who might share or have the technical knowledge that is of interest to those people who are doing their PhDs, get in contact with them, talk about ideas and research proposals, and then sort of develop a proposal and submit that as an idea to our HDR group. And as I said, I think the conversations with staff are very important, and finding the right type of supervisor is key to the success of a PhD or the failure of a PhD.
Yeah, great. Thanks so much, Steve. And I think there are also some deadlines for the application, for the PhD applications, which I think is one coming up for international students on the 31st of August, and then the domestic students would be the 31st of October. Yeah, other than that, I'll recommend going through the staff list, or even through the members of the Climate Change Institute, which you can also access through our Fenner page. Maybe there are some people that you can ask for advice, or also willing to be a supervisor if they are here at ANU. And I think we are running out of time and are actually going over time already. So Pete, you're back with your video. Do you want to have any final comments for us, or for the people still that are still joining us?
I'll just thank everyone who joined us for the session today. Great questions, and thanks so much for our wonderful panelists. If you do have further information, I've typed in the chat window our email address and also the website of the Fenner School of Environment and Society. We're always happy to hear any questions, and lots of the academics are, as you said, Mel, I'm quite happy to answer questions as well.
Absolutely, yeah.
So you can search through their list, and an email address is usually there as well. So, but yeah, we might sort of wrap it up there, Mel.
Thank you so much. Yeah, thanks for everyone, and really enjoyed it. I hope it was helpful.
All right, thanks everyone.
Thank you. Bye now.
Bye.